So for part B of this question, they are asking, is the rate of change increasing or decreasing? So if they were asking if the height of the water were increasing or decreasing, I would look at dH/dt, but they're not. They're asking for the rate of change. They're asking if the rate of change is increasing or decreasing. So that means I need the second derivative. I have here the first derivative, I need the second derivative. So since I'm going to take a derivative, I took my dH/dt equals -1/10 square root h, rewrote it as -1/10 h to the 1/2 power. So now I can just get the second derivative. So I have to go d squared h dt squared equals, so I'm going to multiply the 1/2 using the power rule, -1/20th h to the -1/2. But here's what I have to watch out for is because I'm doing the derivative of a function in h, but I'm doing with respect to t, this is still an implicit differentiation. So I have to put a dH/dt on here. Now, we want to know what's going on at the point when the height of the water is 3 feet. So when at h equals 3. So I want to know d squared h dt squared evaluated at h equals 3. So I'm not going to go of 3 because that would be t equals 3. So I'm going to see evaluated when h equals 3. So that's equal to -1/20th times 3 to the -1/2 power times, well, I need to know what dH/dt is, and dH/dt is -1/10 square root h. So I can replace that dH/dt with -1/10 square root of 3. Now, I can look at this and sort of work out what it is, but what's probably much better is to just look at this and say, I have a negative times a positive times a negative times a positive. What I get is positive. So I don't have to work out exactly what it is. The only thing that matters is that d squared h dt squared at h equals 3 is positive. So, I mean, if you really want, you can say this is equal to -1/20 square root 3 times negative square root 3 over 10. That's a negative right there. The square root 3's cancel out, and so we get 1/200th. And the College Board solution sort of revolves around the fact that the derivative is always 1/200th and the h cancels out. But I would argue you don't really need any of that. All you need is that the derivative when h equals 3 is positive. And then probably just since it says explain your reasoning, we need to answer the question and explain our reasoning. So the rate of change of the height of water is increasing at, let's say when, because we don't have a time, when h equals 3, because d squared h dt squared evaluated at h equals 3 is positive. And that's all we need to say. So it's nice, it's good to answer the question, reference the problem, it's the height of the water, and state that that's increasing, give a time stamp to it. One of the earlier problems, I neglected that. It's probably important to do that because, and here's our reason, because the second derivative is positive, which we found up here. And that's part B.